that most of you guys probably know about as much about this, if not more than I do. So I wanted to be super, super careful about not going over stuff that you already know. So please, if I do that, forgive me. I've tried my best. So this is maybe going to be, if not personal, it's certainly going to be what I've tried to share in the past. And I wrote this book over 10 years ago now. So it's very much, this isn't plugging a book. The book's long since sold out. I couldn't care less either way. So hopefully you'll just enjoy this for what it is. And maybe we can have a little bit of a discussion afterwards about perhaps your own favorite things to view where there is a bit of light pollution.
Actually, your book is available in the US still. I just ordered it on Amazon. So.
Oh, well, there we go. Probably remaindered copies at this point. If any of you, when you write books for Springer, and Springer crank out these astronomy books, 3, 4, 5 of them a year, you get paid a lump sum up front, and then you don't get royalties. Or at least I certainly didn't. So once the thing's out the door, you don't care what happens to it. Anyway, but the reason that I wrote it, the reason that I was interested in this particular topic, and I'm going to hold something up, which is a book I'm sure lots of you have got, Stephen James O'Meara's books on Messier objects, Caldwell objects. This is his book on hidden treasures. Was as fabulous as those books are, I didn't find they really helped me. When I bought my first proper telescope, which was it was a Celestron First Scope 114. I'm not sure if they still make those, but a 4.5-inch reflector. And I was looking under Suburban skies and stuff. I was finding these books were written by people who live, out in Arizona in the desert somewhere, or halfway up a mountain somewhere. And what they were seeing and what I could see were not the same things. And I found that incredibly frustrating. And so what I wanted to do, what I set about doing, was trying to collect information from other astronomers of things that I could see from my back garden. Maybe the place to kick off with is why I think a go-to telescope is really, really useful. And how many of you have go-to telescopes? Am I talking to people? Right, good, okay, right. Because I know there's a lot of snobbery about this in the hobby, isn't there? And I certainly, when I kicked off in the hobby 20 years ago, I guess, it was all about learning the sky, that you should learn to star hop. And that's great. I mean, in and of itself, that's terrific fun. And I don't want to diminish that at all. But at the same time, I think we shouldn't be snobbed about go-to telescopes. And if you live somewhere where the skies are not perfect, the fact that you can have a telescope, well, nowadays you just switch it on, don't you? It does GPS and time and date. It does it all for you right from the get-go. And it just points at what you want to look at. And that's, I think, a huge, huge advantage. And that lets a lot more people spend more time looking at things and thinking about what they are looking at. And we're going to make some diversions. I'm going to suggest a few things that I find rewarding that perhaps are overlooked, and perhaps think a little bit about why they are interesting. But when you look down the telescope, sometimes when I'm sure lots of you have been in this situation before, when you have, if I ask my wife to look down the telescope with me and she's like, well, what am I looking at? And you said, well, that fuzzy thing that you can just about see out of the corner of your eye. And she's, well, what is it? Well, it's globular cluster, whatever. And she's like, well, I can't see any of it. And sometimes you have to sort of think a little bit about, well, what am I looking at? And that makes it interesting. In and of itself, it's not particularly an attractive object. I mean, some things are beautiful, but a lot of things, they're just very dull to look at through a telescope. But once you realize that this is perhaps a star that's very similar to our own, or a nebula that's 10 light years across, or whatever it is, once you can add some context to it, it becomes that bit more interesting, I think, anyway. So perhaps other people will have their own opinions on that. I was going to kick off with a little think about workarounds, and I suspect some of you will have opinions on this, and I will really enjoy listening to what your opinions are on those, on things like deep sky filters, because if I have 3 astronomers that I'm talking to, I'll get 5 different opinions on them, and they just seem to be very, very divisive. Some people love them, some people hate them. It's just really, I find it really interesting how people use them differently. I'm going to focus on objects that are visible during summertime. I hope for obvious reasons, but the idea, perhaps this might spur you to go and look at 1 or 2 of these things that I'm going to mention if you don't already. When I wrote the book, the way that I arranged it was not by constellation, but by season. And I also did a thing which people found a little bit peculiar, but I arranged them all by their NGC numbers, which is not how most astronomers think about these things. There are thousands of things in the NGC catalogue, so you can't possibly remember them all. But the handy thing that I discovered quite quickly is if you stick with the NGC numbers, you can flip between them very quickly on your go-to telescope. You're not constantly scrolling backwards and forwards between different catalogues. So you're not going, I'm going to look up the Messier objects here, Caldwell objects there, NGC numbers there. You can just stay on one catalogue, and that makes things much, much simpler. Do any of you have your telescopes connected to a computer? Yeah, right, good. And when I was writing astronomy software reviews, there were some things which were kicking out, which were these things for writing, like observing lists on your PC, and you connect it through the serial port, connect it to your telescopes, you go bam, 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 bam through them all. I always found that fiddly. I found it easier to go through it myself. But I can see how if you've got a computer-controlled telescope, particularly in a permanent observatory, that would be a fabulous way about doing it. I'm not going to talk about astrophotography. I know nothing about it, absolutely nothing. And so if I say something doesn't look very good to me, I mean, to the naked eye, I'm sure it looks fantastic through a long exposure photograph. The Bortle sky, where you are, could you give me some idea of where you are on the Bortle sky darkness scale? Any ideas?
I'd say probably a 7.
About a 7?
When I moved here, I could see the Milky Way from my front yard barely, and now I can't see the Milky Way at all from my yard. So
yeah, I'm
yeah,
seeing nodding there. I mean, that's if I say it's a universal experience, forgive the pun. But I think a lot of people move somewhere and the skies are quite dark. And as the time passes, it seems, despite what everybody tries to do.
Yeah, most of us are outside Orlando. There's a few of us that live on the outskirts. I know we have some members who can see the Milky Way from their house, I'm sure. I bet she lives out a little ways. Yeah, Lake Mary, where the planetarium is, and I think I know about where Frank lives. There's quite a few of us that live closer to Orlando than out and about. And Orlando's a pretty big city, so.
Yeah, where I am, it's probably about a 6, maybe a 5 on a really good night. It seems to vary a little bit. And I'm about 30 miles out of London now. When I lived in the US, when I lived in Lincoln, Nebraska, it was around about maybe a 5. But then if you went sort of 10, 15 miles out of the city, the light pollution dropped off pretty quickly. And that's probably not uncommon in the Midwest, where you've got sort of one city and then really nothing. I guess if you live in more built-up places with lots and lots of suburbs and things, maybe you're not going to be so lucky. But that's the Bortle scale up there. And I'm really thinking about what can you see for maybe a 5 or a 6. I guess a 7 is really, that's not much fun for deep sky at all, is it?
No.
So
it's great for the moon and the planets.
Well, yes.
And some clusters, open clusters do all right,
Yeah. And there is that idea that if you increase magnification, it reduces the ambient, it increases the darkness, supposedly. I've never found that's worked terribly well for me, but people say that it does. Right. Anyway, let's move around. I mean, talking about the workarounds, I've mentioned about go-to telescopes. I think we all know what these are, so I don't really spend too much time about it. But obviously for people living in the suburbs, I think the fact that they can find the object for you, so you don't have to star hop, you're not limited by what you can see through a 30 or a 50 millimeter finder scope, I think makes a massive difference. I think they've changed the hobby out of all recognition, really. Filters, broadband filters. Do any of you use a broadband filter on a regular basis? Yeah, okay, nobody. This seems to be the thing, that when you start off in the hobby and you see the advertisements for these things, you think, these things sound fabulous. They get rid of light pollution. And then you try one out and you're like, meh. And that does seem to be the thing, doesn't it? So that's, $100 down the drain. So people just don't bother with them anymore, as far as I can tell. Whereas the narrowband filters really are superb. I'm seeing some nodding there. Do most of you use or have access to narrowband filters of one sort or another?
Yeah.
So by the narrowbands, I'm talking about something a bit like perhaps the old Orion Ultra Block. That's one of the best ones. It's been kicking around since forever. And then maybe those line filters like the O3s and the H betas. Yeah.
Yeah, I've used an O3 for visual.
Yeah.
Same here.
Yeah. If somebody asked you which to pick out of the three, what would you go with?
I use my, depends on the aperture I'm using. For smaller apertures, I use the ultra high contrast.
Yep.
For larger apertures, like my 11-inch or 16-inch, I'll use the O3. Yeah.
I think I'd probably go along with that, though I will say this, that the very best view of the Veil Nebula I've ever had was with my 76mm refractor and an O3, a 2-inch O3 filter. It was absolutely mind-blowing, but that was under a dark sky, pitch black, dark sky, middle of nowhere. But yeah, I think that's probably, in terms of, if you're giving advice to somebody starting out, the Ultra Block is probably the one to get, isn't it, for a 3 or 4-inch refractor or a 6-inch reflector. The O3s and the H betas perhaps a bit less. I can't off the top of my head remember the last time I looked through an H beta. Has anybody used one of those recently? No? I mean, the O3 is pretty damn useful, but the H beta is it perhaps a little bit better if you're taking photographs rather than visually? I don't know. But the O3, I find that I use that a lot. That's almost my go-to now. It's just so very, very versatile. But of course, the problem with all of these narrowband or line filters is they block starlight, so they're of no value at all for obviously for galaxies, but also for reflection nebulae, which I think is sometimes overlooked. One of the little things that was shared with me that I wasn't aware of, and perhaps some of you already know this, is that you get the best results from a filter if you get the exit pupil right. And you want it to have an exit pupil that matches the particular filter, and most of them fall in a range of about 3 to 7 millimeters. So if you've got your standard 10 Schmidt-Cassegrain, a 32mm Plössl is going to give you a decent exit pupil that goes really well with that filter. But stick a 10mm eyepiece in there, and the exit pupil is now too small, and you won't get the optimum contrast. And it's kind of fun to try it out yourselves at home and see which works best. They put it to work brilliantly with all of your eyepieces and all of your telescopes. There are going to be combinations. And when that was shared with me, it was a bit of a revelation, because nobody had ever told me that. Certainly doesn't say that on the instruction leaflet. So it's kind of a fun little one to go away and have a little bit of a diddle around with and see what you find yourselves. Any of you have one of these, a reducer corrector? Yeah. Okay. So yeah, and these I think it was Rod Malise got me onto this. Uncle Rod, I believe he refers to himself on websites, but he considers them to be essential, and I think he's probably right on that. I basically leave it on the back of the Schmidt-Cassegrain pretty much all the time. They're superb things, and they give you, if you've never used one before, what they do is they reduce, they shorten, I think is probably the correct phrase, the focal length of a telescope that they're attached to. They're usually for for compound telescopes like Schmidt-Cassegrains. Can you use them on Maksutovs? Not 100% sure on that. I can't think why not, but I don't know. And they flatten the field, but they also allow the telescope to behave almost like a rich field refractor. They give you that short focal length that allows you to see much wider fields of view, which can be really good if you're trying to look at big objects. Not necessarily ideal if you're looking at globular clusters, but if you were looking at not planetary nebulae, at open clusters, supernovas, remnants, that kind of thing. Last but not least, I mean, this is a throwaway thing, but if you're using a go-to telescope, you don't want to be using the batteries if you can possibly help it. I think I'm right in saying that most people who go wrong with them, that you have problems with them, it's the batteries are dying or too cold or something. And I'm sure, am I the only person here who's found their telescopes slowing down through the night and not tracking things anymore, and you've got to rejig it, and it actually turns out the batteries are dying. So if you can get away with that. What I thought I'd do in terms of talking about objects, and really please do sort of stop me, and if you have your own ideas of things we could talk about on this, absolutely please do, is I'm going to suggest a few things that are worth looking at under suburban skies using go-to telescopes in summertime. And when I wrote the book, the way I thought about arranging it was to kick off with the showpiece things, the things that everybody's going to want to look at, the Orion Nebula type things. Then talk a little bit more about the sort of more challenging objects. And then you've got the obscure things, which are going to be either very, very tough or very difficult to see for some other reason. Perhaps they're difficult to recognize what you're looking at through the eyepiece. And last but not least, I'm going to mention a few stars. I think individual stars tend to get overlooked a little bit. So hopefully I'll give you some suggestions of perhaps some stars that you might have a look at if you haven't already. The pictures that I've used, and one of the things I think is really important, and I don't know if you feel the same way about this, is when you look in an astronomy book, is to see a long exposure photograph alongside the description. And you're looking at that photograph and then looking in your telescope, and two things just don't look the same. And so one of the things that's really important to me is to suggest to people, well, this is what you're going to see. This is a really, really fine globular cluster. M80, I think, is the one everybody knows in Scorpius. But M4 is perhaps a little bit less familiar. But one of the cool things about this is that this is presumably quite an easy one for you guys to spot close to the southern horizon. Am I right in saying that? Do you get a good view of the southern zodiac? Yeah, because it's a dog to see from England, an absolute dog. It's really, really difficult. Sagittarius and Scorpius are awful. I mean, if anything's Aquarius, once people, the heart sinks. And so you can imagine what it feels like if you're a British astronomer and they say, oh, have a look at this thing in Scorpius. You're just thinking, well, I'm never going to, it'll either be light pollution or trees or houses in the way. It's really, really tough.
The question for you.
Go on.
What's your latitude where you're at? I think we're down here, we're at 28 degrees, somewhere there.
Well, that's the thing. It's about 53, 54.
Wow. I moved down from Ohio, and that was...
Oh, my goodness.
That I noticed a much better southern objects just from Ohio down here, but 54, that's...
Yeah.
Ohio's
That's
40.
got to be on the horizon, right?
Some of these barely, they don't even rise above the horizon. They can be it's really, really tough. And can you imagine if you're a planetary observer and you want to look at Mars,
right,
which is only ever close when it's in a southern constellation? So I'm sure you remember, how many years back was it when we had the really close?
2004.
2004, and it was frustrating,
right?
Because it was this huge object, like an orange marshmallow in the sky, but you were looking through light pollution, so all you saw was flickering. So when I moved to Nebraska for a while, and that's 10, 15 degrees further south. It was a revelation. So things like the Rosette Nebula, things like M4, M80, M22 suddenly pop into view. When I used to have holidays with a then girlfriend, had a house in Stewart in Florida.
Oh yeah.
Which I'm sure some of you will know, that part of your state. And I could just about make out with the refractor Omega Centauri. Yes, I think it was Omega Centauri. And you couldn't see a lot, but I could see the damn thing.
Right.
And you can see how big this thing was. And it blew my mind. So for a British astronomer, seeing anything like M80 or M4 is a major achievement. But the reason I plonked this here is that if you've got reasonable southern horizon, this globular cluster resolves really nicely. And this is one that you don't need a lot of magnification to start seeing some of the stars. I'm sure you're well aware of that. How many of you seen the little sort of the cat's eye thing running through the middle of it? Yeah. Well done. Yeah, good. And it's nice, isn't it? It sort of, I can't see it full on. I've got to do sort of averted vision to see it. Perhaps some of you have better night vision than I do. It's kind of a cool one because it's considered to be a very loose globular cluster. So it's very, very spread out. It's not quite the loosest. There's one or two that's sort of on the borderline, aren't they? Between open clusters and globular clusters, like the wild duck cluster. I think is one that sticks in my mind as being almost as if it can't make up its mind what it is. I wanted to make a little diversion onto globular clusters, and I'm going to guess at some point or another you've had a speaker come in talk about globular clusters.
No, but we need to, because they're like my favorite thing visually to look at.
Aren't they just?
Yeah.
Was it? I'm trying to remember who described them as crushed diamond dust.
Oh, that's a good one.
Was it Guy Consol?
I said that. You mean I'm not the first one to figure that out?
Okay, so it's Richard Wright. That's how to remember next time I say it.
It was me in Florida.
Okay,
yeah,
but
absolutely. Yep.
It's accurate, isn't it? You've got enough aperture.
It is. Mm-hmm.
It is. They are crushed diamond dust. They are absolutely spectacular things, and I love looking at them.
And no photo. And I mostly do astrophotography, and I will tell people when it comes to a globular cluster, there is no way to photograph a globular that matches the view through an eyepiece. It's unparalleled.
It seems to me, I think with the photograph, you get the brilliance, you get the colors and all of that, but through the eyepiece, you get that three-dimensional quality, don't you?
Yeah, and just the dynamic range. Your eye can see more of that range than a camera or computer screen. No matter how you stretch it, no matter what you do, it does not match. And there are several objects actually like that are just the eyepiece is better than any camera. So I'll shut up.
Yeah, now. I mean the Orion Nebula is like that as well, famously, isn't it? The good bits are overexposed in a photograph. So
it doesn't it look? It looks so different in a photograph. The view through an eyepiece, I've never seen an image. Sketches, yes, but I've never seen an image of Orion that looks like that ethereal, ghostly magic that it looks like through an eyepiece. It just can't be captured. And actually, as a technical guy, it's computer monitors are what the problem is. But anyway, you have to have an eyepiece. You just have to look through a telescope to see it.
Yeah, your eye has such a different resolution rather than looking at a flat screen. You know, you can pick up so many variables in light, and your brain adds a bit of dimension to it too while you're looking. And for someone who hasn't seen these objects, globular, Orion Nebula, in a scope, and you describe it to them when they're looking at it or going to look at it, then they really appreciate the description, and they see it, and a little bit of their imagination takes over on what they're looking at and appreciate it more, I think.
Yeah, they are absolutely. They are my favorite deep sky. They never fail to lose their charm, and it's kind of certainly this far north. They really are very much a spring summer object. You don't tend to see particularly good ones through wintertime. So there are something to look forward to each year. And I absolutely, I think this is, you've got to get a guy to come, or a lady to come in and talk about them. There is so much has changed over the last 10, 15 years in our understanding of these things. I certainly remember sort of 20 years ago, the idea was, well, okay, we know these globular clusters, they appear to be 14 billion years old. The universe is 13 and a bit billion years old. How does that work? We've since refined those models. We understand a bit better how old these stars are, and they're providing us with, when did the Big Bang happen? Had to be at least to the age of the globular clusters ago, and they are full of these population 2 stars. I love the idea that astronomers refer to them these population 2 stars as being metal poor stars, because astronomers basically, everything that's not hydrogen and helium is metal, and so these stars are essentially mostly hydrogen and helium, but then so is our sun, but it's got marginally more of the heavier elements, and obviously the solar system around the sun does. And what these globular clusters, some of you probably already know about some of this, but the gist of it is I'm going to try and get to where it is. Ooh. The gist of it is the very first population of stars from the Big Bang had no metals in them. When they collapsed in themselves, became supernovas, they created elements heavier than helium. Those seeded the second population of stars, which is called population 2. When the population 2 stars collapsed, they produced even more of the heavier elements, that the metals, what astronomers call metals, which became the population 1 stars. For some reason the numbers go backwards, never been clear to me why, which include things like the sun and the planets around the sun, presumably. What I found surprising when I was learning about this, though, is that these population 2 stars are actually still the most common. They far outnumber stars like our sun, but all of these population 2 stars are in these globular clusters. They're very condensed, as well as being in the core of the Milky Way and other galaxies, presumably. So even though when you look at the night sky, and we're looking at the constellations and all the rest of it, we're mostly looking at these sun-like population 1 stars, they're actually the minority, which I found to be a bit of a surprise. I found that quite surprising. Let's just, very aware of the time, so I'm going to sort of zip on a little bit through this. Now, this is because I can only see the sucky globular clusters. This is what is the 3rd brightest one in the sky, is the best one you can see from England, which is the Great Globular Cluster in M13. Is that meh for you guys, if you can see the ones in Scorpio? No? Yes?
No, it's still my favorite. Omega Centauri is a close second, and down at the Winter Star Party, which is held in the Keys every year, it's sort of like you've not been unless you've seen Omega Centauri, and everybody stays up late to see it. But M13 for me is still my favorite. It's just because it was my first one, I guess. But it, yeah.
Yeah.
It's not
okay.
me. No, M13 is still pretty awesome globular. It holds its own.
And it's just about naked eye visible, even under my sky. So I can look at the right part of the sky and then put my binoculars on it, and start to see it rather better. It's always good value. One of the things, the little factoids that I liked about this is, I'm sure most of you know the Arecibo radio telescope. This is one of the ones they sent a message to, with the theory that there are lots of stars there. So if you send a message in that direction, perhaps aliens will pick it up. Or at least that's the way the story's told. The reality may be more to do with calibrating the damn thing, who knows. Are there any planets around stars in globular clusters? It seems pretty unlikely. Tidal forces and all sorts of things probably get in the way. And the fact that these are metal poor stars would mean that if there are planets, they're going to be gas giants rather than rocky planets anyway. That said, was Arthur C. Clarke wrote a splendid story about astronomers on a world orbiting a star in a globular cluster, and every sort of once every 1,000 years, it happens that the stars are not in the night sky. So the sky goes black, and everybody goes bananas because they've never seen a dark sky before. And I found that a funky sort of idea. M92 is the other one up in Hercules, which I always like. And this has always been a good fun one for star hopping too. It's at the top of the Hercules sort of, what do they call it? What's the stone shape?
Keystone.
Has at the top there.
Keystone.
Sorry?
The keystone of Hercules.
Keystone. That's the one. That's the one. That's the one. Yeah. And you just sort of go up in a sort of triangular shape, and there it is. I'm hand waving here, going out of screen. Forgive me that. But it's a good one, and again, it's one that resolves nicely. This is going to be an easy one for you guys, surely. But it's a great one for testing out filters on. If you've got O3 filters, this one really does reward you. It's a superb one. I've never had any luck at all seeing the reflection nebula. Any of you done any better on that? No, it's really tough. I wouldn't even know where to start on that. So again, like you say with the photographs, what you see in a color photograph, a false color photograph, usually, of one of these things versus what you see in the eyepiece, very, very different. Let's sort of move on. This photograph you've all seen before, the Pillars of Creation, the Hubble Pillars of Creation. And this is taken in that nebula, as I'm sure you're well aware. But that nebula has told us quite a lot about how stars get to certain sizes. Why do some stars end up as giants and some stars end up as dwarf stars like our sun? And at least part of the explanation seems to be that when we look at these pillars of creation, we're seeing the gas and the dust being pushed away on jets. And once that material is pushed away from the protostars, that puts a limit on how much material can condense onto that star and become eventually collapse and become a star. So that's become a really important nebula for people to study. Ring Nebula, I think, is that an obvious pick, really, isn't it? Because it's straight upwards. So it's going to be in the darkest part of the sky. And I think, can you see the Ring Nebula even if you've got sort of a fairly light polluted skies where you guys are? Is it an easy enough spot?
Over at the Orlando Science Center, we've got a 10-inch refractor, and we can see the ring from downtown Orlando.
Right. Yeah.
It's rated at a magnitude 9, but it gives a nice wide surface area as a target. And as long as you tell folks what they're going to see, then they'll see it. They'll see it.
Yeah.
But you know, we can get that.
Any luck seeing the star in the middle of it?
Haven't resolved that for them to see, no.
No, that's a tough one. I'm not sure what the minimum aperture is for that, 10, 12 inches, something like that. But yeah, it's a great one. And it's a really fun one I'm sure some of you do this blinking technique where you put the filter between your eye and the eyepiece, move it in, move it out. And then the surrounding stars dim while the nebula doesn't. And that can be really useful trick if you're doing like a street star party with people who don't know what they're looking at.
Right.
And it'll pop into view. It's a lovely object. And the diameter is something about the size of our solar system or something, which is kind of an interesting thing when you're looking at it. It's when I say the solar system, I mean, out to the Oort clouds or something. It's a fair old size. But that's what you're looking at, which I find really quite cool. You don't sort of get a sense of how big the solar system is. And the Ring Nebula, I believe, is sort of order of magnitude of the size of the solar system. Okay, those were the obvious picks. The more challenging ones. Has anyone had any luck with the Veil Nebula? Yeah. Did you use a filter or without?
With an O3 filter here.
Right.
Yeah, it's
gotta be dark.
glorious with an O3 filter with enough aperture.
Yeah. And this one is always going to be a challenge under suburban skies. It's not very forgiving at all. But with sufficient aperture, as you say, and the right filter, it's doable. At least the brightest bits are. And if you've got a go-to telescope and it's calibrated and working nicely, if you tune it into the Veil Nebula is sort of broken up into lots of different NGC objects, but to 6992 or 6995, you'll get the brightest bits, and it should be as obvious as it's going to be. But you want a wide eyepiece, a wide field of view eyepiece, and if you can, the reducer corrector on the back of a Schmidt-Cassegrain. If you've got a like a Dobsonian or something, I guess you're laughing. That's a very cool object. This one, how many of you have even bothered looking in Lupus? I mean, talk about obscure constellations. And this one's quite low down on the southern horizon. Certainly, even in Nebraska, it was pretty low on the horizon. But it's kind of a nice, actually quite bright globular cluster. And this would be one that if you haven't looked at it, give it a try, because it's small enough, it sort of condenses that brightness. So, it's not the brightest globular cluster out there, but it's small. And it basically looks like a planetary nebula. I don't think you're going to resolve very much of it. But you can see that it's got some texture to it. And it's a really cool little object if you've not had a chance. Has anybody had a go with this one? No? Okay, so maybe that's one to put in your shopping list next time you're out.
Yeah, not in a long time. Not in a long time. So that's worth looking at again. Right? That's worth looking at again, yeah.
Yeah.
I hope everybody's taking notes, right?
Well, you've got. I will send the slides off to you at the end, whether it's Tricia or whoever would like. If they're happy enough to receive them, I'll send the slides off, and you can do whatever the heck you want with them. Be my guest.
Tricia will be happy to receive the slides. Yes.
Okay. Cool.
Yes.
Of course.
Yeah, I don't want to jam up anyone's mailbox, but if she's happy to do that, I will absolutely do that. NGC 6520, an open cluster in Sagittarius. I mean, if you're looking in Sagittarius, you're usually looking at globular clusters or nebulae. But this is a cool little open cluster that has a dust cloud, a dark nebula. Has anyone had any success spotting the ink spot? No? It's certainly worth trying. If you look at the diagram that I've put up here on the slide, you can see I've inverted it to make everything easier to see, frankly. Certainly when it was printed, it makes it easier to see. But if you can see where I've got the red arrow, there's a white patch, and that's an absence of stars. There's nothing physically there you can see. What you can see is an area where there aren't any stars in a really rich star field. And that is apparently a dust cloud of some sort that's passing between us and that part of the Milky Way as we look at it.
Where were you when you made that drawing?
Yeah, so it's got some fans.
Where were you when you made that drawing of the previous object?
Oh, these were all done using computers. This is all done. I used Starry Night Pro for this, and I diddled around with it in Photoshop.
Now, you observed this in your backyard, or?
This one, yeah. I've seen this one. Not in England. Not in England, though. This would be in Nebraska. This would not even be above the horizon here, or barely. So, yeah, this would be... could you see it at all in England? You'd need a really low horizon, maybe the sea or something, to have even a vague chance. Anything that I've seen in Scorpio, Sagittarius, Lupus, those will be done in Nebraska or in Florida or in California, but not here. Not a chance. But this will be a lot higher up in the sky for you guys, presumably. What does Sagittarius get to where you are? 20, 25 degrees above the horizon? Something like that. It should be well above well above the dust and the horizon.
Yeah, easy, if not more. If not more.
If not more.
If not more, yeah. Oh, Sagittarius, you've got a complete view from here.
Good.
Yeah, I'm showing 30 degrees above the horizon.
30 degrees. That sounds about right.
Or
That's
65, 20.
Yeah, like right now, it's like at 25 and it's going up. So
Okay. Yeah, trying to think of these numbers off the top of my head is not the easiest thing in the world. That sounds about right.
I'm
So
cheating, of
30
course.
degrees in Orlando, it's going to be 0 degrees, minus something in England. So this would be impossible to see there. I'm trying to think if there are any dark nebulae you can even see from here. I don't think there are, because we don't get that part of the galactic core really clips the horizon. The Milky Way, the parts of the Milky Way that we see best here are going to be the bits going through sort of Perseus, Cassiopeia, that sort of thing. Right, 6818. This is just another little planetary nebula, very overlooked one because nobody goes looking for them in Sagittarius, but definitely a fun one. And in that field of view with all of those quite bright stars, you won't see it. It'll be very difficult to spot. But if you move the filter in and out of your field of view, it will snap into view instantly. I've mentioned NGC 6572 in Ophiuchus. It's a very similar planetary nebula, but one with a bit more colour to it. I don't know where you are and whether it's blue or green. That seems to divide people a little bit. Lacerta. Now, these are much easier for me to see. Do you guys get a good view of Lacerta up in the northern sky? Yeah, no. I mean, Lacerta is one of those constellations people don't look at. It's a sort of a ziggy-zaggy shape, a little bit like Cassiopeia, but much dimmer. And this is a really nice one because it's got this open cluster that is so spread out, about half a degree across, that you really need a nice big wide field of view to get a good view of it. But when you look at it, it's really pretty and easily seen, even under suburban skies. Like a lot of these open clusters are actually quite forgiving. So if you haven't had a look at this one, do give it a whirl. A few obscurities there. Now these, you get extra points if you've seen any of these, frankly. This open cluster in Aquilia. How many of you even bother to look at Aquila? Oh, okay. Yeah, it's this huge constellation with hardly anything in it, isn't it? So out of curiosity, what is it that you like to see in it, or what do you go looking for? Eric.
Well, there we are. See if we can find this 6709, and it's part of what we talk about being part of the summer triangle.
Yep.
Over at the Orlando Science Center, because you have a lot of folks who show up over there who are willing to listen to see what they can find up in the sky, and where it's at.
Yeah.
Easily located, because I guess like fishing, you go out fishing a few times and you catch fish, you're like, oh, I enjoy this. So
yes.
It's like, all right, let's give them some bait to see some things and try to give them a little bit of a challenge, and that to see if they can find these things on their own. And so this is one of the indicators that we try to look at through our telescope to see and show them actually how dark or how infringed with light our atmosphere is from that location.
Yeah, and I think you mentioned the summer triangle there, which is almost a kind of Patrick Moore, I think it was, coined it, didn't he? But is there a better starting point in the hobby than learning your way around that summer triangle? Alberio, the double, then you drift off to find the coat hanger, Sagitta.
Right. I'll tell you what, once you show them Alberio as a starting point and the contrast between those two beautiful stars, Yeah, they get. It would be like looking at getting a telescope, looking up at the sky, seeing a bright object, pointing your scope at it, and finding out it's Saturn or Jupiter. Then you're like, oh,
Yes.
You get blown away. So.
Yeah. I mean, my wife jokes that when a fourth or fifth date, whenever it was, and I showed her Saturn through the telescope, that was when she decided she was going to marry me. I think she's being generous to me, but it does have that effect, doesn't it? If you show people the right object, you've got them for life.
Like meeting a musician, and then you finally hear them play, and you're like, oh my gosh,
Yes.
Blows your way.
Yeah.
You don't think the rings of Saturn had anything to do with wanting to marry you, right?
I'll have to ask her that one. Yeah, I mean, Saturn, are you guys getting good views of Saturn right now?
Beautiful.
They suck.
Well, if you get these clouds out of the way.
Yeah.
Well, if I could get, half the Earth's hemisphere out of the way, I'd get a better view. So I'm really jealous of you guys. You've got Saturn, Mars, and Jupiter.
Right.
All way down in the south. So you guys are getting great views. They're lousy here. In fact, I enjoy planetary astronomy more than anything else. If I'm going to drag the telescope out, it's going to be the refractor, not the Schmidt-Cassegrain, for a quick look at a planet. That's become, in terms of astronomy, I'm a quick look guy. They'll spend 15, 20 minutes having a look at a few old favorites because I've got to have an early night to get up in time to go to school the next morning. I'm a school teacher, a science teacher. So the luxury of staying up to wee small hours doing deep sky stuff is unfortunately long since gone. And right, this year has been a washout for planets.
Oh.
There's just nothing in the north.
Yeah, because they're so low on the ecliptic. I mean, they're so low on the horizon right now.
Yeah, I mean, you get Venus. Venus is like, yeah, okay, just shine a flashlight in my eye. Why don't you? There's like nothing to see there. Anyway, so that's a bit of fun there. And another one in Aquila, which is, I don't know if any of you had a go at this little planetary nebula. It's similar to the Ring Nebula, but with dimmer. Doable from suburban skies with the right filter, but you don't want too much light pollution. I mean, it does need to be, I would probably think maybe a 5 on the Bortle scale for this one. You might maybe a 4. I think you're going to struggle at 3. But as I say, these ones are a bit tougher. Here's a great little one, which is an open cluster in Cygnus. I know Cygnus is full of open clusters, so no surprises there. But this one is really, really old as open clusters go. Most of the open clusters that we're familiar with, especially things like the Pleiades or the Praesepe, are really quite young, sort of tens of millions of years old. And this one's age is apparently in the billions of years, which is really unusual for an open cluster. Which is probably why the stars are all so spread out at this point. But really, really cool. It's also quite nifty in terms of the history of science part, in that it was discovered by Caroline Herschel, who I feel as if 10, 15 years ago, hardly anybody knew about her. But she's now become almost a part of popular culture now, that when you are introducing women in the STEM subjects, Caroline Herschel is like Marie Curie. She's one of those characters you bring up, to show that there have been scientists, women scientists going back a long, long time who've achieved great things, but for one reason or another, their contributions have been forgotten. My daughter was given a book about Caroline Herschel by one of my friends for one of her birthdays. She seems to be sort of well established. So it's quite a cool one to bring up when you're doing sort of that science communication stuff. I'm sure a lot of you are very involved with. I was going to round out with, because I'm sort of conscious of time, and I know that I've been sort of rambling on for a good half an hour now, it feels like, with a few stars. So I know this is not everybody's cup of tea, but I was just going to slap up a few stars there, and maybe that can sort of prompt a little bit of discussion. Stars are often overlooked, but if you think about them for a suburban astronomer, stars are really, really forgiving. Individual stars are going to be quite easy to see. And your go-to telescopes have gazillions of them in the database. So zooming your telescope round to them. there are obvious ones like Albireo and the double double that we could all talk about and enthuse about. What I wanted to throw up were a few maybe obscure ones that maybe you haven't looked at in a while, but are well worth looking at. And I'm kicking off at the top with RS Cygni, which is a variable star. And I'm sure you've had speakers come in and talk about variable stars. I know they're very sexy in some quarters of amateur astronomy, aren't they? But it's a carbon star, and I love carbon stars. I think they're such beautiful objects. Do you guys get good views of Cepheus where you are? It's one of the circumpolar constellations. And it's got a star which is known as the Garnet Star, at least in England, which is a really deep red, almost like a port wine colour. Really, really beautiful. And when I saw that for the first time, I really fell in love with these carbon stars. They're absolutely beautiful. As I'm sure you know and have been learned about yourselves, that red colour is caused by apparently clouds of carbon soot forming on the surface of old stars that are no longer just turning hydrogen into helium. They're now fusing the helium into the heavier elements, such as carbon. Am I right that stars can only do that up to iron and then they stop? Is that right? Yeah. And then everything above iron, it's a supernova. Does that sound right? Yeah. Okay. I'm not an expert on this.
Because there isn't enough energy. There isn't enough energy in that star to turn that into what's the next one? Cobalt. And that would be extraordinary, which can't happen.
Right. Okay. So even the temperature and pressure in the star is not enough to make that happen. You need a supernova explosion.
Right.
Which
Correct.
tells you something about what a supernova must be like. They must be. I wouldn't want to stand up close to one. So you've got this rather.
Not for long.
Sorry.
Not for long.
You'd be vaporized in seconds, presumably. It'd be like that Thanos click thing. It's well worth. Yeah, we're all doing it now. It'd be well worth. It's well worth looking at, and it's very variable. I mean, 6.5 to 9.5. I don't know how many times dimmer that is, but that's a lot. 8 Lacertae, so going back up into the constellation of the Lizard, is a 7-star system. SAO 72509. You can see 4 of those stars quite easily through, say, 200 millimeters, about probably 150, frankly, but 200 easy. Resolving the rest of the system is very, very tough. But you can see 4 stars in that 7-star system, and they are apparently 7 stars orbiting each other. It's not just 7. It's not an optical double. They are literally orbiting each other, which, as I've been told, which is actually really, really interesting. 95 Hercules. Anybody looked at that one before? Whenever I look at them, yeah, they look like Christmas tree balls to me. It's the silver and gold next to them. They just make me think of Christmas, which for a summer constellation is a bit weird, but they're very, very pretty. And again, we've been talking about Albireo, talk about these stars that you can show newcomers to the hobby. And 95 Hercules is a fabulous one to show somebody because the colours are absolutely spectacular. 16 Vulpeculae, there's a really tough split for a 200 millimeter telescope, 0.9 arc seconds. Do any of you have any fun resolving tight doubles? Yeah, okay, yeah, so I'm not the only one. I've never done the thing with sticking a hair on an eyepiece. Have you ever tried that before? No? No, it's have you heard of it though? It's a thing.
No, I haven't tried that. What is that?
You're going to have to go and look out how it's properly done. But my understanding is you tape a hair onto the eyepiece and you can move that onto the brighter of the 2 stars and it will block the light so the other one will become sort of visible.
Huh.
That's the theory anyway. It sounds very old school. No idea if it works, but it sounds cool.
Yeah, I'm old school.
Well, yeah. Yeah. New Scorpii, it's just another double-double. It's tougher, but it's another double-double. So if you enjoy, is it Epsilon Lyrae, you're going to enjoy this one. It won't resolve so easily in a small refractor, but if you've got a big enough reflector or Schmidt-Cassegrain, it's a fun challenge if you've got good seeing. Rho Capricorni, there's a double hidden in a double. So the double itself of the first, there's 3 stars there, but 2 of them are easily resolved. But one of them, the brighter of the 2, is actually 2 stars, and that's much tougher, but a challenge and well worth doing. RY Sagittarii, I'm not sure I've ever seen this one myself. Has anyone had a look at this one? It's another one of these carbon stars, another red star. But look at that range of variability, 5.8 to 14. That's a terrific range. So 5.8 is pretty bright. That should be easy enough to see under most skies. But 14, that's going to be a challenge. So there's going to be some nights it will be visible and some nights when it's not. And it's one of those really unusual variable stars in that it's not regular. The light doesn't follow a pattern. It's completely random. And it seems to be just patches of carbon bubbling up to the surface on an unpredictable, or at least not to a pattern that astrophysicists have established yet. And last but not least, going back to Lupus, which is one of those constellations I enjoyed looking at when I was in Nebraska. Can't really see it here. Pi Lupi, and you've got these 2 beautiful snow white stars, 1.6 arc seconds apart. So they're quite easy to see. Maybe a little bit tougher to tell, to separate with a small telescope, but they shouldn't be overly difficult. They're quite bright, should be quite straightforward. And that was what I was going to wrap up with. That's, as I hope that's been entertaining enough, or at least certainly worthwhile, to give you some ideas of things that perhaps you haven't looked at before under suburban skies. There are other objects out there, and I'm absolutely not plugging the book because I don't get any more money for it. Borrow it from the library for all I care. PDFs float around online. I could not care less. But the book was designed as basically lists and lists and lists of things you can see under suburban skies, but with some descriptions. So if I sort of hold the thing up so you can see what it's like, if I hold up a typical sort of page, it's sort of like this, that there are pictures of what you're likely to see, but with a whole bunch of text about it. So that when you are looking at what you're looking at, you have an opportunity to perhaps reflect on what you're looking at. Because I think with a go-to telescope, because you're not learning the sky, you're not doing the star hopping thing, there needs to be another reward. And I think for me, at least, the reward is learning about what I'm looking at. So I spend a bit of time at the eyepiece, perhaps sketching it. I know that's a thing people like to do, but certainly spending a little bit of time thinking about what I'm looking at. What makes this globular cluster particularly interesting? How far away is this planetary nebula? What sort of star am I looking at? And then there are things, these ambitious things like splitting difficult double stars, which is good value. So, I hope that's been worthwhile to you. And
yes,
I'd say
absolutely.
Ask questions, but you guys probably know more than I do.
No, we do. When the world's not falling apart, our club does quite a bit of outreach, and I bet a lot of the other people who did outreach were taking notes, because it's always a struggle to find things to show people in the parking lot at Starbucks, for example. And it's like, oh, we got lots of planets, and we got the moon, yay! But if you don't have the planets and the moon, it's a stretch to find. There's a small list of things, and of course, it depends on what kind of scope you have with you. But
Yeah.
No, those are great points, and look forward. We're going to circulate your slides for those who didn't take notes when you send those in. So I thank you very much. I don't think I saw any questions on the chat. Somebody was asking about the field of view, and I hope I understood correctly, but I saw the field of view is actually marked on those images. So if I misunderstood, you should probably pipe up now on the group chat. and we can ask them about it.
Yeah, the field of views are on those things. I have a horrible feeling that I have put arc seconds where I meant arc minutes or vice versa on some of them. The text is correct, but on the slide, some of them may be wrong. It will be, what matters though, if you have a look at it, is it tells you what the combination of eyepiece and aperture was. So it should be fairly obvious what
I remember one of them was 30 arc seconds, and thinking of it now, that's only the width of like Jupiter or something.
It's almost certain. And one of the reviewers, when the book was published 12 years ago, picked me up on that the text is correct, but the captions are wrong. And that's mea culpa. And if I ever do a second edition, I'll go back and change that. Oops.
No.
I've probably got a PDF of it kicking around somewhere. If I share that with Trisha, maybe she can share that with you guys so you can have a little flip through yourselves within the book.
Well, thank you. And what time is it there now?
It is coming up. It's about 1:05 in the morning.
Yes. So thank you. Yeah. So those who joined late, we let Neale start a little bit early because it is 1 in the morning where he is, and we didn't want to keep him up too late. And so we do have some other mini programs and things to continue with. And feel free to hang around if you're bored and just can't sleep. But
I may well do a mute for a while and just see what you guys are up to. But I will probably go to bed shortly.
I have heard some of our meetings can help you go to sleep, but I don't know. I'm hoping that won't be the case. I'm hoping that will be the case tonight.
Not true.
Yeah.
It has been an absolute pleasure. Thank you so much for the invitation.
Yes, thank you.
Thank you. I've enjoyed it very much. And best of luck. And in these difficult times, I trust you will stay safe and stay well.
Yes, thank you.
Have a good night, all of you.
I'm going to take over your screen share.
Thank you. That's that.
And share mine.
Oh,
right. And then start my thingy. See if this goes right. All right. Welcome to the August 2020 Central Florida Astronomical Society. Thank you very much, Neale, for your very informative talk. We did have some technical difficulties, so I'm sorry for the late start and anyway. It is all recorded. I saw the little recording flash thing, so I know Frank is on the job, and we will post a link to the YouTube channel if you missed the very beginning of Neale's talk. So we do have some cool things to talk about. We are going to talk about sketching a little bit tonight. One thing I want to announce ahead of time is next month's meeting. We'll be starting an hour early, not for the general meeting, but we're going to do a 1 hour public, which means non-CFAS members can attend, how to pick a telescope. So what we're finding out in my world is right now during the pandemic, everybody is staying at home, and people who have money to spend or have jobs are getting stimulus checks, and nobody can keep telescopes in stock. So lots of people are buying telescopes. Lots of people are getting into astronomy right now. So it is an opportune time. We were talking about doing it around Christmas time. We thought, maybe we'll do another one after Christmas. So we're going to promote it publicly. I'm not sure how we're going to do it technically. We do not want any Zoom bombers crashing it. It is going to be public questions, but we're going to have the top minds at CFAS with telescopes talking to you. Frank is also going to be there, but I could not find an embarrassing picture of Frank, which just shows that Frank makes good choices when it comes to social media. But the rest of us, goofed off a little from time to time. But Eric and I and Derek and Frank will be entertaining questions from the public and talking about how to pick a telescope. Is a refractor better than a Dob, or should you get a Schmidt-Cassegrain, and those sorts of things. So lots of people buying telescopes. It depends on what you're doing, Eric. It's down to be, imagine, what was that show with the movie critics that would always fight with each other? It's going to be 4 of us fighting with each other. So it should be very entertaining. We should probably sell tickets. We could raise a lot of money for the club. Okay, so our first mini program, though, is on my schedule. I don't know if she knows it or not, but Sharife is next on the schedule. Sharife, are you here? Sharife?
I am.
I hear you. Yes. All right, I'm going to stop sharing my screen so that you can share your screen, and we're going to pay attention to you for a little while. I love your work on Facebook, and
I'm disabled.
I'm
Let me
very.
give you
Oh,
permissions.
yes, we need to give you permission.
There you are. Hang on, hang on. There you go.
Cool. All right. This. And, all right, can you guys see that?
Yes.
Like, giant.
Mm-hmm.
All right, so I'm going to be sharing some of my art that I have. Some of you know from seeing my stuff on social media that I'm self-taught artist and have been drawing for about 10, 15 years, something like that. And I do a lot of pen and ink work. And recently I started doing some astronomy and space art. And it's kind of taken off into this fun project where now I'm kind of incorporating mythology and some planetary stuff and seeing what comes, what shows up. So usually I have, this is the kind of stuff that I usually draw. So a lot of art with my dog, Anubis, which you guys are probably familiar with. And then some animal stuff. So I have usually some funny animal things, but let's see. Recently I started with Artemis. So I wanted to kind of get a glimpse of what I would imagine Artemis, the goddess, would look like. And so kind of incorporated different parts of mythology, looking up what she represented and who she was. And so the Greeks called her, I won't go too much into the mythology, but more of the art process, and you're welcome to jump in and ask me questions at any point. But yeah, so I'll usually start out with just kind of an outline, doing a little bit of research about the mythology and what the image that I want to convey. When I start a piece, typically I have no idea where it's going to go. And then the more that I add to it, it kind of just starts to get life. And then there will be a point where the piece just kind of clicks, and then it just kind of gets its own momentum. And yeah, so I'll start with just a pen and ink background, just sketching out with pencil, and then going in with, I just use microns and just pens, regular pens, and they're all waterproof. And then I'll go in with ink. So I have just ink. I'll do India ink, a couple drops of this with diluted in water, and then I'll do kind of a wash and then take it from there. So in here you see the moon, obviously on the bottom, and let's see, this is the finished product. And yeah, so you see Artemis, and then I have the original right here. So it's kind of hard to see on here, but you get the idea. And she's with nature and with the, I'm not sure what planet is in the back. I hadn't really kind of evolved in that part yet, but the moon and a couple other planets there. So then I decided to go with planets, and so I started with Mars. And I started with just sketching the Mars as the god of war and certain symbolism that he would have associated with him. So the horse and chariot was a symbol that I found a lot of. And then also I decided to sketch opportunity, curiosity, and perseverance. So the other two rubbers are hidden, I guess. But figured I'd personify them in some way. And so I drew them up on the hill. So that is Mars, the finished product. And there you go. So I figured I should add some potatoes or something, you know, like Mark want me inside joke, but I might go back and add them later. And then here you can see, actually, I'll show you. Let's see, I have perseverance, opportunity, and curiosity here. And next, decided to go with Jupiter. So sometimes I will get help from Anubis, my dog, and you can see the setup I have on the bottom, in the middle, and then similar setup. He was described as having ambrosial curls by Homer, and so the reddish clouds in the drawing, they're all India ink, and watercolor also. I decided to do them like the planet, so what I would imagine the planet would look like. And the final product for him is this. So, yeah, kind of hard to see. And then the one I have been working on for a while now. That's the final product. I decided to do some stippling with this. That's typically what I'll do, and then kind of mix it up a little bit. And the last one that I've done is Venus. This is the most recent one. And yeah, so Goddess of Beauty, Love, Laughter. And I have Earth. This is where I'm at so far with her. And so I have Earth, oops, wrong way. Earth, and then Mars back here. And she was described in mythology as coming from sea foam, from the foams of the sea. And so in the descriptions having silky ringlets. And so I decided to come up with this. So yeah, so that is it with her. And what I'll probably do, I'm still not finished with her, probably about another hour or so of work. And she's all stippled and stuff on her face. I'll probably do, let's see, Mercury next, and he'll probably be a funny comedy one, how I would imagine Mercury to be personified, and then I'll probably do Earth and do her like a shaman or something. I don't know. But anyway, so that's an ongoing project, and I'm happy to share them as I develop. They'll probably get a little bit more unified as I do more. So yeah.
Okay. It. Well, thank you very much, Sharife. This is really great, and I just want to encourage anybody watching. It's the Astronomy Club. We all are interested in astronomy, but that manifests in a lot of different ways. We don't just take out a telescope and look through it. Obviously, we have people who do photography as well, but we also have a lot of people where astronomy infiltrates their crafts. Or other things that they're doing, or even if you're into the science of astronomy and you have your own study. Last month, Bill gave a talk about variable stars. If you're studying something in particular, just a few minutes to share what it is that you're doing. Everybody else in the club would love to hear about it. I've been following Sharife's stuff on Facebook. It's like, you need to show this to the club. This stuff is really great, and I think it's really awesome. And I hope that encourages some other people to also share.
Would be cool.
Some of the things they're
I'm hearing Neale's drawings and descriptions. It'd be neat to kind of add them similar descriptions of kind of what I do in the telescope. You gave me an idea to look and then kind of add them in the background for some of these things. Of like, like a little hidden cluster or something.
Yeah.
I'll stop sharing.
Very cool.
Yeah.
Okay.
So, that's it.
Sharife, I got a question. This is Bill. I'm an engineer. I have no artistic style at all. And I do like to draw things in the eyepiece now. Where would you go to get some kind of art lessons or anything to do better at art?
Honestly, I'm like I said, I'm self-taught, so it's just been a matter of practice and trial and error and seeing what works. I mean, I have a lot of drawings that I didn't like, and then just going at it and continuing to practice. Somebody had mentioned, Samira had mentioned the Coraldi School of Art. I mean, right now you could probably YouTube a lot of art tutorials and just kind of practice certain styles and techniques and seeing what works.
So can you guys see my screen?
Can. And that. Yeah.
Any other questions for Sharife?
Well, I see some comments. Yeah, thank you guys.
Yeah, great work.
It was a little intimidating sharing my art because it's always been something that's very personal and very vulnerable, but I appreciate it.
That's fantastic.
Yeah, thank you for sharing. Thank you very much. It's great. It's definitely better than my artwork. So our next program sort of ties in, we're going to talk about the Astronomical League Observing Program of the month. And actually, Bill wrote me and made a suggestion, and so I followed that, Bill. First, though, why the Astronomy League Observing Programs? Everybody in CFAS is a member of the Astronomical League, and they have dozens of these observing programs that are great structured self-teaching ways to learn more about astronomy or learn more about your particular favorite thing in astronomy. So if you think you might be interested in variable stars, or you might be interested in globular clusters, there are observing programs that will actually teach you about those objects. And they actually have an observing program called the Sketching Observing Award. And this is my very first sketch of the moon. I'm going to keep this and show it to you forever. Even when I get really good, I'm going to keep dragging this out and saying, I sketched this on the hood of my car, and this is where I started. And so I am sure wherever you start, it can't be any worse than where I'm starting when it comes to learning to sketch. Why sketch? The sketching program is pretty simple. It does recommend at least a 6-inch telescope so that you get enough aperture to see the things. But it's not meant to turn you into an artist. It's meant to force you to slow down. I've often made the same observation about astrophotography. If you look at a bunch of objects in a night with an eyepiece, you spend all night imaging an object, and by the time you process that image, you know that object very intimately. And I think sketching is a very similar sort of experience where you are really studying that object in order to sketch it. And so the point of this is to slow you down and make you pay more attention to what it is that you're observing and to record the details. You'll remember more about the object because you sketched it than if you just looked at it for a really long time. Honest, that is how that works. And you have a permanent record of your observations and a justifiable feeling of accomplishment. Here's some sketches of the moon made by Galileo. Immense scientific value at the time. Don't let anybody tell you that your photos or your drawings have no scientific value. Whenever they say that, they're talking about no scientific value that's of interest to them. I've never met a scientist who did not understand the difference between qualitative and quantitative data. And I know I'll ruffle some feathers when I say this, but I sure met a lot of amateur astronomers who did not understand the difference. And they're usually the ones that are browbeating their fellow amateurs because they're not being serious enough about what they're doing. Anyway, I'll get off that horse. The observing program, there are 75, actually there's 114 objects, and you can pick any 75 of them, depending on which ones are most appropriate for your viewing location, and they come in different difficulties. So, it kind of walks you through, start with some simple things. For me, a simple thing would be an open cluster, just to draw the dots with the right spatial relationships to one another. And again, it's not meant to turn you into an artist. It is meant to get you observing and paying more attention and refining your observing skills. And for the program, in order to get the certificate that you can brag about and that little pin that you can wear to star parties, you're not allowed to sketch from photographs. So you can't just get on Google and sketch the pictures. That's great if you just want to sketch, but this is the sketching observing program. So this is how to sketch at the telescope and so forth. And from everything I've read, I have not gotten very good at it myself. I certainly do not have Sharife's skill. You'll be surprised at your progress over time. The documentation looks surprisingly like the quote official CFAS observing log, the official unofficial CFAS observing log. Just some circles, record the instrument that you're using, the date and the time, and all the information, and start sketching that object. And sketching, it goes from very subjective, just recording it, to there's actually some very serious Alpo program exemplar sketching, and those things get recorded and archived for scientific use. I also found a couple of books. The one on the right on astronomical sketching I didn't get, but I actually bought the Sketching the Moon book. I bought it on my iPad and read it on a flight somewhere. I had a long flight across the country. And it has what Bill was asking, some techniques. How do you make something? And you start with the main the outside shape, and you start putting in the shading, and it sort of layers into it. And I am not even barely qualified. I am barely qualified to tell you about it, much less I am not qualified to teach you how to do it. But I'm just going to tell you that's a source that I found useful for sketching. And if you want more information, visit the Astronomical League website. If you decide to do it, you can turn in the forms to me directly, because I am the Alcor coordinator for CFAS, and I can get you your pin and certificate. If you want to go straight, if you want to be bashful about it, though, you can go straight to the source, Cindy Crotch. I'm not sure how you say her last name. Haleakala Amateur Astronomers in Maui. So they're the ones who came up with this observing program for the Astronomical League. By the way, I also found it very interesting. Most of these observing programs are created by people in astronomy clubs. So if you, I'm not sure there's a carbon star observing program, but there may be, but maybe there's not. And Neale could go, hey, I'm going to create a carbon star observing program, and he could put that together and he could submit that to the Astronomical League, and that could become an official observing program, and people could learn all about carbon stars and things like that. Okay, so that's the Astronomical League Certificate of the Month. I'm looking at my notes. Next is astrophotos. Now we've talked about sketching. Let's talk about astrophotos. Hang on a second, though. I need to rearrange my desktop a bit. There we go. And I'm still sharing. So I'm going to pause. If these are your photos, I'll give you a chance to say a little bit about it. If you're not here, well, you won't care, but I'm going to wing it. Laura Kelly, are you present? Speak up or yell or jump up and down. She did tell me she may not be able to make the meeting tonight. But this is actually a photograph, not a sketch. And it's actually one of my favorites because I've done this a couple of times myself, take a photo and not just turn it black and white, but a noisy photo, when you turn it black and white, it looks a lot like a drawing. To me, this looks like a sketch, like somebody drew it there. But she told me she took this at the Kennedy Space Center. So she was there after dark, and she got Comet Neowise photographed. Near her home, she's got a new house near an airfield, and she got the comet over the airfield as well. And she also went to a SpaceX launch and took this. I think this is a really nice photo. I love the smoke billows at the bottom. Turned out very nice. So close to Earth photos. Now taking us out a little bit, I know Frank Kane is here. Frank, you want to tell us about your Zombie Brains Nebula here?
Yes, absolutely. It's actually the Crescent Nebula, but yeah, it does look more like a zombie brain to me too. Yeah, this is actually combined over 2 different years of observing. So I combined some data from last year with some data from this year for a total of 9 hours of integration time on this one. And yeah, it's just a pretty little nebula. It's I think it's one of those ones that has like a little Wolf-Rayet star in the middle that's kind of like blowing out a bunch of gas around it. And if you look closely, you can see kind of like that blue oxygen shell around it too. That's something I was trying to capture this year. So from a technical standpoint, I'm pretty happy with that one.
Yeah, that halo is pretty nice.
Yeah, this one's called the Elephant's Trunk Nebula, but I kind of put it at a weird angle here, and it looks more like a moose to most people now. So, yeah.
It does look like a moose.
Yep, it's Bullwinkle.
I can't
You will never unsee it.
I can't unsee that now.
I'm sorry.
I had some children.
Watch me pull a rabbit out of my hat.
I had some children at an outreach event. I was doing live stacking, and they said, if you turn it, it also looks like a mermaid with her back to you.
Huh.
And she's like, I see a mermaid. And I'm like, but if you turn your head, it's like, yeah, that's a mermaid.
It's like a
But
dragon.
now this is also a bullwinkle. Yeah, that's definitely a moose. Pretty
It's totally
awesome.
a moose. Yep.
Yeah.
But yeah, this is like the last one. This is done with narrowband filters,
Okay.
so it's all false color. So in this one, I kind of like made some color choices. It makes it look even more like a moose.
Yes.
yeah.
The coloring really helps a lot too.
Yeah, it's about I forget, like 5 hours of exposure time on this one.
Excellent. From your driveway.
Yes, from my Winter Springs driveway.
From your driveway.
Bortle 7, as we were saying.
And I think, hang on.
I think that's mine.
Yeah, this one's yours. Yeah, this one's yours. I have another one from Bill,
Yeah.
co-string, but this one's yours.
Yep, that's my Jupiter, also from the driveway. Yeah, so this is actually taken back in May, and I did like some new processing tricks on it this month to make it look even better. So I'm like super happy with this one. Like that's pretty good detail for a driveway. And it's also a good testament to the importance of aperture in planetary imaging. I recently got a C11, and this is like my second try using the C11. It is so much better than a C8. So aperture matters when it comes to resolution on planets.
Yeah, it does. Thank you. Those are great. Next up, Bill Costring. Are you still around?
I'm here. Can you hear me?
I can hear you. Tell
Yeah.
us about your Saturn.
Yeah, a couple of weeks ago, it was clear. which was strange for having it clear on a weekend. So I figured I'd go out, and I got this Jupiter. It was the Saturn here. It was a 5-minute capture with my ASI 224 MC camera and 9.25 inch SET. I got a total of 134 frames per second while I was capturing it, and that was a 25% stack of the 40,000 frames I got total for it.
Wow.
And stacked it in auto stacker and used the Registacks for the wavelets and sharpening. Come out pretty nice. I was pretty happy with the scene that night. Started out horrible, and then all of a sudden it was like somebody flipped the light switch and the atmosphere calmed down and just went beautiful.
Nice. Was this on the same night?
This was on the same night. I had no idea that this was going to happen. We had, I believe that was Io on the face of the moon there, and its shadow was following it across the moon. It was just a pleasant surprise. So that was a 2.5-minute capture at 300 frames per second, and also a 25% stack from 5,000 total frames. So that came out rather well too. I was real pleased with that one.
Thanks. I think it's true in all forms of photography. The more persistent photographers are the ones that wait for the opportunity, or the ones that get, they get the bird, or they get the capture. And this is one of those nights you have to set up and be in the driveway when it happens.
Absolutely. Seeing can change in a matter of seconds. And I've heard that before, but I'd never really seen it until that weekend. It was like flipping a switch on.
Wow.
It was amazing.
Nice. All right. Well, thanks for sharing.
One thing I'm seeing here, this is Bill C. Been noticing the red spots actually getting redder again, and it's getting smaller over the years.
It has been getting smaller, yes.
Equatorial zone on when the red spot, is there, is getting a little darker too.
I think it is. I think it's been going from that peachy color to a little bit more redder.
Yeah, it went. I'm going to date myself here, but observing it from the impact back in 1994, Shoemaker Levy 9, and where it went really, really pale, where you could hardly make it out from Earth. You had to get closer, so I couldn't afford that. But yeah, it's darkened up a lot.
It's really exciting. I know a lot of the planetary imagers, one of the things that's a thrill for them is, especially this planet, very dynamic, and it changes all the time. And because so many people are photographing it, we're going to have a record of the evolution of this red spot. There's going to be a 300-year period where we're going to see what this red spot did over the course of months and years. And that's going to be very invaluable, undoubtedly, for, trying to figure out the atmospheric dynamics and all that sort of thing. So very cool. I hope you're submitting some of these photos to Alpo for their archives.
I have not been.
I encourage you to do so. Same for you, Frank, as well. Well, we're going to have to change that. Yeah, we'll get you going. Bruce Donzati, if you're here, you can interrupt me. But he told me he didn't think he was going to make the meeting, but he sent these pictures in. This is a really nice M27, the dumbbell nebula that he captured. I don't think I have any details. This is the, Neale Galaxy. I'm pretty sure this is the Neale Galaxy. Correct me if I'm wrong. Anybody out there got a more photographic memory? Neale Galaxy. Witch's Broom are part of the Veil Nebula. This is one of my favorite nebulas. We were talking about this earlier tonight. This nebula is really fantastic in O3. When you have some aperture, you can literally see the 3D structure. All of this red and green is basically a big tube in outer space, and you can see that with a proper filter with a big aperture. And that's another one of those things where just visually, it's just so much more stunning than you can produce with the photograph because of that ghostly, ethereal thing. I'm going to get off topic just a little bit. I helped. I do software, right? I helped a scientist in North Carolina with a study by writing some custom software for him. And what he was doing, he was studying human eye sensitivity. And when something is very bright, you have a hard time telling the difference in brightness when things are very bright. But when things are very, very dark, the eye is actually extremely accurate at seeing slight differences in brightness. And this was a topic that was also covered earlier. There's a scientific basis for this. When you magnify an object under light pollution skies, it spreads the light out and it gets dimmer, but it spreads the background light out the same amount that it spreads the foreground light out. And because it's dimmer, your eye is more sensitive to the slight changes in brightness for a very dark, when the light is very low, than it is when the light is very bright. And I thought that was pretty cool. I also had a photo of the Pelican Nebula in HA, hydrogen alpha. It's very interesting. The one on my slide has got some big lines through it, like somebody wrote on it. Are you guys seeing that? I don't see it, no. Now I am going to turn the Pelican over on its side because I remember for a long time I didn't see a pelican, and my wife actually said, well, look, there's the head of the pelican and the beak, and there's the eye and the kind of the back of a pointed head. I'm like, it's a pterodactyl, not a pelican. I would buy it's the Pterodactyl Nebula, but it's pretty cool. Okay, now that's all the photos I have, except I just want to say it's July, and I normally make excuses it's August. I normally make excuses all through July and August. The weather in Florida is terrible for astrophotography. You can't do astrophotography in Florida in the summertime. And here's a handful of CFAS members who basically told me to shut up because apparently you can do astrophotography in the summertime, especially if you are patient. Okay, so let's see what is next on the agenda. The Observing Challenge, and what's up this month. So the Observing Challenge, I'm going to start with Bill Castro turned in. He is our only taker on last month's Observing Challenge, which was the Lunar Maria. So Bill took some images here under different lighting conditions. That was one of my challenges, is on the moon. Look at these things under different lighting conditions. They really look remarkably different. It's not like Jupiter, but one of the reasons I so much like the moon is, and I actually like the moon more than deep sky photography, the moon changes almost on an hourly basis. You can see the shadows and the lengths of the shadows shortening and growing, and it's a very dynamic target. And also, the little inset here, I mean, he took this with a cell phone, or is that a little point and shoot camera? And actually, Bill, you're here. I should be shutting up and letting you talk. Do you want to say anything about your little project here?
I thought you were doing good.
Okay.
That's a point and shoot camera. Just
okay.
I think I spent $50 on it.
You can't do astrophotography with a point and shoot camera. You have to have a cooled CCD camera that costs at least $6,000, and it's got a, yeah, it's amazing. Yeah, what you can do. I love the moon. When I do my Starbucks outreach, and I'm really starting to miss that, I always have the adapter, and people take pictures of the moon or videos with their cell phone. So they just the cell phone goes right over the eyepiece, and they can surf around the moon, and then they go home and post pictures, and that's like, hey, I went to the moon. It's pretty cool. So this month's Lunar Observing Challenge is going to be on lunar valleys. I've only picked 2 valleys. So I'm going to go a little easy on you this month. First is the Alpine Valley, or Valles Alpes. This is near the well-known crater Plato. This is I'll get my mouse over here. This is the valley right here. And it's about 100 miles. A lot of people look at the moon, they don't know what the scale is. This is only about 100 miles long from here to here. It's over about 6 miles wide. Here, where it's really fat, is only about 6 miles wide.
Nailed it.
Yep. And so that's actually one of my photos. So the Alpine Valley, and it does also, it changes its appearance over the course of the month. The other lunar valley is Schroeder's Valley. This is the largest valley on the moon, or the longest valley. It's 115 miles. So if this was a big piece of thread and you laid it all out like this, and you stretched that thread out, it would be 115 miles. It is about a little over half a mile deep, 0.6, or it's a kilometer, so 0.62 if you like. And it's near the crater Aristarchus, which is a better known crater as well. So that's your two lunar observing challenges: is Schroeder's Valley and the Alpine Valley. So what else is going on in the sky tonight? So Derek couldn't be with us tonight. I'm going to do what's up tonight. Derek is a planetarian, and you will notice real soon I am not. So be sure and tell Derek that you miss him. Tonight, right now, actually, this very second, why are you watching this? You should be outside. No, you should wait and watch this. The Perseids are going on now. And actually, they don't really get really great until midnight or so.
That's where I went, Richard. I went and checked outside. It's overcast by me.
Oh, it's overcast by you? Yeah, I went out last night, and it was pretty cloudy, too.
I saw a few last night, about 3 in the morning.
Yeah, we've had some really good Perseids in the past, which are really great. So you might get lucky. We may get some. If you get a break in the weather, like I said, it's all about opportunity, right? So if you get up early and you go out and it's clear before dawn, you may catch quite a few of the Perseids. Okay, so what else is there to look at this month? Here is. I made a sky chart of the night sky around 10 o'clock or so. So really between 9 and 9:30, it's starting to get dark enough to start doing some observing if the weather is clear. You can see the Milky Way is right overhead, and Cygnus is like almost straight up by the time it's dark. Last month, Derek talked about some of the things that are a little more to the west of the meridian, and talked about M13 and Hercules. So I'm going to focus more on the Cygnus area, or the constellations around Cygnus that you can look at. Cygnus, by the way, if you are doing imaging, especially narrowband imaging, Cygnus is a narrowband wonderland. You can just point randomly in Sirius and open the shutter with a hydrogen alpha filter, and you're going to get some wild, cool, smoky looking, cool things. There is just so much going on in that part of the Milky Way for you to look at. A couple of highlights. M27, and this is your first deep sky observing challenge for the month, is M27, the Dumbbell Nebula. Since Bruce sent us a nice photo of the Dumbbell Nebula, I thought I would put that up there. The Dumbbell Nebula is 1,227 light years away in the constellation, I'm going to totally butcher this, Vulpecula. By the way, I love the way, never mind. It's something that he pronounced earlier. Oh, it was Herschel. It's like I've never heard Herschel pronounced Herschel. I thought that was so cool. All right, the light from this object, get back on topic, Richard, has been traveling for 1,227 years, which is about the time of King Charlemagne in Europe. So that's how old that light is. It goes all the way back to the time of Charlemagne. Our next object is the Ring Nebula, which earlier tonight, a really good suburban target to look at in the constellation Lyra. Easily visible from Lake Mary. I can see it. I've seen it at the Geneva Gun Range. Even in a smallish refractor, you can make out that little smoke ring. Even without even without an O3 filter, it usually comes through. It is a bit further away, 2,883 light years away, which is about 263 BC or BCE, depending on your cultural preferences. This is pre-Julius Caesar Rome, basically. So we're getting back there a ways.
Hey, Richard?
Yes?
A question. On visual observing of that guy, I know our guest speaker said that responded well to filters. I've never had good luck using filters on the Ring Nebula. Has anybody had good luck on it? I like it better without.
Yeah, I've not needed a filter. Anybody else wants to speak up, they can. But I never need to use a filter on this, even from here. I've not tried it from Starbucks, but you know, from my backyard, I can see it.
Downtown at the Science Center, we've got the U8C and a broadband, and so switch it out depends on the evening, but
And that's with a 10-inch.
Sometimes from downtown, you get a noticeable difference.
Okay.
With a lot of light pollution, you need it.
Yeah.
Yeah.
Yeah, and I find my own experience with O3 filters is they don't O3 is not, it's nowhere near like HA is when it comes to light pollution. O3 filters, I get much better results under dark skies with an O3 than I will under light polluted skies with an O3 filter. And that goes both for visual and for photography. I think there's a lot of our light pollution has some O3 in it. Also, moonlight is full of O3 as well.
Yeah, I like trying one of each. Every eye's a little different, and sky conditions are different. So just try it yourself. Your results vary.
Your mileage may vary. I mean, I don't know. It could have something to do with humidity and other factors as well. But here locally, that's been my experience. When I go down to near KPP and that sort of thing under a good dark sky, you know, the O3 filters do much better than they do here. Our final target is the Andromeda Galaxy. It is coming up fast in the east, and if you stay up just a little bit, you can get a good view of that. This is actually a photograph of Andromeda, but I found that the photograph looks a lot like it looks. This one here, this is unprocessed. This is a raw photograph, and it looks a lot like Andromeda looks visually to me in my big 14-inch Dob. And you can see, I don't know how well this is coming across Zoom, but you got this elongated bright area, and you can just barely see these little dark lanes here against that bright background. And I have seen this visually under a dark sky with a sufficient aperture. That is pretty much what it looks like visually. Now, if you put a camera on it, well, this obviously is a camera, but if you do a little bit longer exposure and you stack it, you do all that work, this is obviously, you know, a lot of people's favorite showpiece galaxy because it's just so full of detail, and it, you know, some of those blue areas are actually real. I've seen people say, I've seen some critiques where, oh, they add all this blue and it's not there. It's like, no, the blue's there. I don't always get it. It depends on the sky conditions, but there's a very strong blue signal there. You don't have to always fake that. This, of course, is a big boy. It is 3 degrees wide, which is about the size of 6 full moons stacked side by side. So this is really a huge galaxy, and you can see it under a dark sky naked eye, but it's just a tiny little fuzzball. All you see is this tiny little bit right here when you see it visually naked eye. It is 2.5 million light years away. And we were not building cities in Europe or anywhere else 2.5 million years ago. In fact, 2.5 million years ago was the beginning of our last ice age. So the repeated glaciations of North America and that sort of thing was getting started when this light left the galaxy that we're watching now in our backyards. So our August observing challenge objects then. Some great summer objects. M27, the dumbbell. I guess it was Messier's popular. M57, the and M31, the Andromeda Galaxy. And you know, I've been trying to encourage people to sketch it, but you know what? Go out and photograph these and send us your photographs as well. That also will count as part of the observing challenge. So photograph these, observe them, and sketch them, and send them in, and we'll be sure and recognize you for the next meeting. So, and thank you, Bill. He's been a real example for everybody participating very regularly. Okay, so I hope I haven't forgotten anything. We're down to Elaine. I wanted her to wrap things up. She's got some whimsical things to talk about as we close out the program. Yeah, so Elaine, that's a hint to you. Be getting ready. I'm about to say, yeah, you're next. So yeah, Elaine, you're next. And we may have to figure out screen sharing with you. I'm not sure you've had a chance to try this before.
I'm disabled at the moment.
Okay, so Frank will make you a presenter.
Yeah, on it. Hang on. Trying to find you in the list of attendees here.
Yeah,
Are you logged in as Elaine, or
Yes.
somebody else?
First name only.
I know I saw you earlier.
I was browsing through. There's like iPad. Like, I don't know who iPad is.
Oh, there you are. Okay, hang on. You are now a co-host, so you should now see a share screen option at the bottom of your screen.
Yep, and I'm going to turn off my screen share.
Well, I had it before, but it was disabled.
Yes,
back now,
he has to make you a co-host. We don't want random people sharing things. It tends to not work out well.
There we go.
Yeah, I can imagine.
Bill, I love your shirt. I just had to jump that in and say that. All right.
Okay, for some reason this is not coming up at the beginning, so
That's
There
all
we go.
right.
I'll go back to the beginning.
We're a very forgiving group.
I understand that. Okay, earlier when you were talking about the drawings, you talked about how we look at astronomy in different ways, and I have a few bits and pieces definitely looking at it different ways, which I call in the news. And a while back, we talked about science as art, and an article from the Wall Street Journal had talked about using haikus to make astronomy more approachable. So I have a couple here. The moon shines brightly, full in the nighttime heavens, a beacon to all. Gaze at the night sky in wonder and amazement. What does it all mean? Stars, planets, the moon, comets, galaxies, comets, clusters, galaxies beckon from afar. And these can all be used in outreach, or you can have people at your outreach write their own haiku. Full moon lights the night sky, casting shadows in the dark. What secrets lie there? And I've put a couple on the group.
Hey, there was a whole thread on the Group's IO mailing list about astronomy haikus.
Well, did a few there, but here's a special one. Frank's trees block some views, frustrating his observing. I have a chainsaw.
Yes. Best poem ever.
So that's for Frank.
Very ominous.
Okay, there we go. Some of the screen prompts were covering things up. A couple of books came up recently in a book review in the newspaper. Soul Majestic, which is about power and spirituality. The Long Way to a Small Angry Planet. That's a book that has a lot to do with politics. And then one that some of you have probably heard of, The Restaurant at the End of the Universe, which is part of the Hitchhiker's Guide to the Galaxy. And it focuses on adventure. But one thing these three books all have in common is food of the future, and what makes it up and the struggles having to do with food. And food got me thinking about cosmic booze. Now, what would be the first thing you would think of when talking about cosmic booze?
The Pangalactic Gargle Blaster. No?
Amen.
How about moonshine?
Oh.
There was an article in the newspaper recently about moonshine. Of course, it's called that because it was made and transported by the light of the moon. And it used to be clear, unaged whiskey, but it now can be any type of liquor. Had its peak during Prohibition, and they did it illegally to avoid taxation. They also called it white lightning, which is another celestial reference. But it's now made in many small distilleries. And that got me thinking more about cosmic booze. So we have the sun. We have the moon. We have the stars.
Clearly, people like to name things after sky things, right?
We have the planets. Now we have Mercury, Venus, Mars, Earth. Back to Mars, because that was Mars and Venus. Then it skips a little bit. Jupiter, another Jupiter, and then my favorite, Manhattan Project Plutonium 239 Coconut Porter. Can't imagine. But other cosmic boos. Yes, they do like to name things after the sky, rocket fuel. But my other favorite, Left Hand Galaxy Cowboy Nitro. And when I was working on this, I got to thinking, now am I showing up? Do I have my camera on? Because I can't see myself.
We see the top of your head, like from your nose up, but we see your slides.
Okay.
Which is all we really care about. But
I was going to show my collection, inspiration. I have a midnight Stellar's full moon, and these were just ones I happen to have. 7 moons, red star, celestial cider. Now, a couple of people have participated in this. My Eclipse vodka, the special commemorative done for the lunar eclipse. My sister was out walking one day and she brought me home Elysian space dust. Cam was already crushed. But I also have imported from Northeast Georgia, some of the real stuff, some moonshine. But if you have to go out and get your own, there's a bar apparently in Sanford called the Suffering Bastard Bar, and they make something called the Astronaut. It's a variation on the Jet Pilot. First 3 ingredients are rum. 3 more ingredients also contain alcohol. And it said it will knock you right into the stratosphere. Discretion is advised. But other times, astronomy comes up. This was in Kiplinger's magazine. They're talking about charity reviews, but they're using an astronomy theme to illustrate checking out a charity. And then there's isolation activities, creating a starry night sky in your ceiling, something the family can do together and learn about the astronomy. And then a little bit of UCF in the news about astronomy. In the UCF alumni newspaper recently, they talked about Snoopy as the industry watchdog for aerospace. And this little figure of Snoopy is in the UCF collection. It was from the Apollo 10 mission. And they have it on display in the special collection at UCF. But it also shows down on the side here, the little silver pin where it says coveted award. That is the Silver Snoopy Award, and astronauts award that to aerospace professionals, and the pins have flown in space before they're given to the aerospace professionals as an award. Something else UCF is working on, and we've talked about this at prior meetings, is tracking the asteroids, and right in the middle there it says NEOs. We just had Comet NEO-WISE. And our guest speaker mentioned the Arecibo Observatory as part of UCF. So UCF has that as an ongoing project. Once again, this is from the alumni newspaper. They try to detect and deflect what they call civilization busters. And they're analyzing each near-Earth object's properties to see what they can learn about them. And then there's the OSIRIS-REx mission. The UCF team discovered that Bennu is shooting out plumes of dust. So UCF is very involved with the astronomy. But to end on a slightly lighter note, some of you may have seen this. And I'm not going to read it for you, but a lot of that should sound familiar.
Indeed.
And it's kind of isolation and appropriate. And that's just some bits and pieces of astronomical references I've come across over time.
Yeah. So if you happen to pick up a few pounds during your isolation, just convert to lunar pounds.
Yes.
Well, you know, on the moon, I'm still doing pretty good. So yeah, that works. That works very good.
Yeah, we can just blame it's gravity.
Yes,
It's
gravity.
causing
All
this
right.
problem.
Well, thank you very much, Elaine, for that. Appreciate it.
And maybe I'll have a little moonshine now.
Maybe I have a friend sent me some from North Carolina. They make it legally. Some places distill it and sell it, and I tried it. You know, you have to. It's
Oh, the lid's awful tight.
not the top of my list. All right. So, all right. So that is wrapping up our meeting for this month, August. We don't normally have meetings in August, so this was a rare August meeting, and I appreciate everyone who's been coming out. We work hard to try to put together a good virtual meeting for you, since we are unable to get all together at the current time, and I'm not going to get into one of those long, in these difficult times commercials. We all know the drill. And I'm very happy that we still have a very vibrant and active community here. And so that's really great. And it means a lot to us. And I look forward to seeing you all again in September. And between now and then, perhaps, you know, on Facebook or on our groups IO. Don't forget about our observing challenges. And we have a few members who have proven to us the skies do not stink all summer long in Florida. There are some opportunities to get out and do some observing or photography. So keep up with it. And thank you again. And I'll see you all in a month. So bye-bye. Bye.